These are video notes on how to add rational numbers. Remember that rational numbers are numbers that can be written as a fraction, and that will also include any decimal that either repeats or terminates. Our first example, we'll do -8/3 plus 5/6. One suggestion I have is that anytime you are adding or subtracting rational numbers, do a quick estimate to make sure that your final answer is reasonable and in line with what you would expect it to be. So in the estimate, I'm going to round each of these two numbers to the nearest whole number. Or the nearest integer. So for -8/3, that's pretty close to -9/3, which would be about -3. And then 5/6 is going to be close to 1. So in my estimate, I'm going to leave that right over here for a moment. My answer should be somewhere around -2, or at least in that same ballpark. Okay, when we are adding fractions, the first thing we need to make sure we have is common denominators. So we need these two numbers to match, and in order to do that, we need to rewrite -8/3 with a denominator of 6. Now, it's not enough to just change the denominator and leave the numerator the same. What you're going to need to do is figure out what you're multiplying by to get from 3 to 6. And since we're multiplying by 2, I'm going to do that for both the numerator and denominator. So -8 multiplied by 2 is -16/6. And since those two values are equal, -8/3 and -16/6, I can substitute that value right below the -8/3. So now I've got two fractions with common denominators, and now I can go ahead and add those together. When I do that, my denominator will stay the same. So I had 6/6. The new denominator will also be 6. And in the numerator, I just need to add -16 plus 5. -16 plus 5, those two have different signs, which means I'm going to subtract. 16 minus 5 is 11, and I had more negative than positive, so that's going to be -11/6. Let's compare that back to the estimate. -2 would be equal to -12/6, since -12 divided by 6 equals -2. So the solution that I got is pretty close to what my estimate was, so I can be pretty confident that that's correct. So -11/6 would be my improper fraction, and then to change that back into a mixed number, you can divide 11 by 6. So 11 would go inside the division box, 6 would go on the outside. 6 goes into 11 one time. Oops. Sorry, 1 times 6 is 6. And when you subtract, you get 5. So this leftover, what you might refer to as a remainder, I can say that there are 5 out of 6 left over. So converting 11/6 into a mixed number would become 1 5/6. And then since it was negative, I'm going to make sure I include that negative in front. So my final answer, when I add those two together, I'm going to have -1 5/6 written as a mixed number. All right, for our next example, we have some decimals, -4 5/100 plus 7 62/100. When you are adding or subtracting decimals, you always want to make sure that you line up your decimal points. Since these have different signs, I can go ahead and subtract the absolute values. So I just rewrote the absolute value of each of those. I put the 4 5/100 below 7 62/100 so that I can subtract the digits. We will need to borrow for this one. And then my decimal is going to drop straight down right here. Looking at the original problem, I had more positive than negative, so my final answer will stay positive. And then I should have done this before, but we can do it now. If I do a quick estimate, I can round this first value to -4. The second one would probably round up to 8 if I'm doing nearest whole number, and -4 plus 8 is going to be 4. So comparing that to my estimate with whole numbers or integers rather, that's pretty close to what I got for the answer. So 3 and 57 hundredths would be my final answer. Okay, for the next set of problems here, I would like you to try these. Pause the video, work it out on your own, and then hit play when you're ready. All right, so the first one, 4 and 8, they have a common multiple of 8. So I'm going to rewrite 1/4 as being something out of 8. So what we can do is figure out what to multiply 4 by to get to 8, which would be 2. And then I'm going to do the exact same thing up in the numerator. So I can rewrite 1/4 as 2/8. And then from there, I'm just going to drop down -7/8. Okay, I have my rewritten values. Just like we saw before, the eighths are going to stay out of eighths, and then I have -7 plus 2, which would become -5. So 7 minus 2 is 5. I had more negative, so my answer is negative. So for this one, -5/8 is already in proper form, so I can leave it just like that. Okay, for the second one, I need to rewrite -6 and 1/3 as an improper fraction. So I'm going to multiply 6 times 3 and then add 1. So I'm basically going around this direction, multiplying 3 times 6, which is 18, plus 1 is 19. So that would become 19/3, and it was negative, so I'll leave that negative in front. And then from here, I can bring down 20/3. So this time the denominators are already the same, so I can just go ahead and finish it off from there. So -19 plus 20 would be +1, and then the denominators stay the same. So 1/3 will be the answer to the second one. All right, and for our third one, we can rewrite all whole numbers as having a denominator of 1, because 2 divided by 1 is the same as 2, and fractions are just another way to represent division. So now when I rewrite both fractions, I can see that I should multiply 1 times 2 to get to 2. So I'm going to do the exact same thing in the numerator. 2 times 2 is 4, so 2 is also equivalent to 4/2, which makes sense because 4 divided by 2 is equal to 2. So now we'll bring down plus -7/2, and we can leave the parentheses there since we've got two symbols separating the fractions. Okay, now I have 4 plus -7, which is going to be -3. And then the denominator stays the same. So -3/2 would be my improper form, and then I can divide to get my proper form. So 2 goes into 3 once with 1 left over, so my divided answer would be -1 and 1/2 as my final answer. All right, and next 3 all are decimal problems. So we just need to decide whether we have the same signs or different signs, and then add or subtract our absolute values. So for number 4, if you haven't already tried these, pause it here, go ahead, work them out, and then you can compare. All right, so for number 4, these have different signs. -12 and 5/10 is negative, +5 and 3/10, obviously positive. So I'm going to subtract the absolute values, and I'm going to make sure I line up the decimals when I do that. So we'll borrow, and then bring down our decimal point. I had more positive than negative, so 2 and 8/10 would be my final answer because it should stay positive. All right, number 5, these have the same signs, so my final answer will also be negative. We can do a quick estimate. -8 plus -4 would be -12, so we're looking for something close to -12. Okay, we'll set that off to the side to compare to. We need to line up decimals, so we're going to add the absolute values. And since I'm lining up decimals, I'll fill in a 0 in the hundredths place. We'll go ahead, add those. And then a negative added to more negative is going to become even bigger negative or more negative. So -12 and 45 hundredths is my final answer, and that's pretty close to the estimate that we came up with as -12. All right, and last one for now, -2 and 75 hundredths added to 65 hundredths. These two have different signs, so I'm going to subtract the absolute values, and we want to line up the number with the smaller absolute value below the number with the larger absolute value. That way we can subtract and borrow when we need to. And then on this one, I had more negative than positive. So my final answer is going to be negative, and I could just write that as -2 and 1/10. All right, thank you for watching, and I hope this helps out with adding rational numbers.